Calibration is one of the most common activities performed in all industries. But the truth is, most of these calibration records are never reviewed and they end up in a pile of documents. The end result is that you never really get any benefit out of this calibration process. Hi, my name is Atanu Datta, and in this video, I will take you through the process of reading a calibration report in a way that you can take informed decisions from it. We'll take two examples. The first one will be a temperature sensor. The second one will be a pressure sensor. So let's look at the first record. So first thing we notice in this temperature sensor record is the acceptable value of the error, which is plus or minus 1 degree Celsius. Let's look at the results. So we have on one side the reference results and on the other side the results of the instrument we are calibrating. We find that there are some differences in the two. This is called the instrument error. In this instrument, the instrument error is within the acceptable limit of plus or minus 1 degree Celsius. Let's look at the last column of the report. There we have reported some values called uncertainty values. Now these are all in the range of plus or minus 1.05, plus or minus 1.06, going to plus or minus 3.36. Uncertainty of measurement is a range of values where it is most probable that the real value lies. So if you take the value of 50.2, it is basically lying between 49.15 to 51.25. So as a result, when you add uncertainty to the error, we might find that some of the values that you measure may be beyond the acceptable tolerance limit for that product. Next, to take the pressure sensor. First of all, the pressure sensor has got acceptable error given in plus or minus 2% of the full scale. For an instrument like a pressure sensor, we measure every point 2 times. First time we measure it by increasing the input pressure from a low to high, and the second time we measure it by reducing the input pressure from high to low. We find that there is a difference in that measurement when we increase the pressure from low to high and when we bring it down from high to low. The reading, for example, 3 actually is 3.009 when you measure it as the pressure is increasing, but when the pressure is decreasing, it is actually measuring 3.007. So there is an error of 0.002. This difference in pressure is called hysteresis error. So if we add the uncertainty and the hysteresis error to a measurement, we find totally different measurements. So by considering the uncertainty and hysteresis of measurement, we can take more informed decisions rather than just considering the error of measurement. I hope you found this video useful. If you liked it, please comment and share it within your network. I hope to see you in the next video. Bye till then.